Hi, my name is Matthias Serbener. I'm Math 2000 here at Challenge 2016, and this is going to be my fourth math video, also the last one. Now, for this one, we have a problem. We have two arbitrary variables. We have 0 is less than little r is less than big R. And you need to find the volume of a torus that is made by revolving the circle centered at big R 0 and with the radius of little r around the y-axis. So the easiest way to solve this is going to be by using the washer method, because if you look at a torus from above, then you'll see that it does look like a washer. However, the radius is going to be a bit tricky to figure out. So the radius at any given point, so to solve this, you need to, for each circle in the washer, for each washer that it's going to be part of the integration, you need to find the two radii, the big radius of the outside and the little radius of the inside. So you can find the area of this circle, subtract it from this circle, and then you can have the area of this space right here. So what you need to do is here, on the x-axis, it's easy because the distance here is just big R minus little r, and here it's just big R plus little r. But that changes as it goes up and down, because this, as you can see, is greater than r minus r. So what you need to do is you need to solve for x, which in this case is going to be this distance. So if we get the equation of the circle just with the standard form, you get x minus big R squared plus y squared equals r squared. And then if you manipulate that and solve for x, then you get that x equals big R plus or minus the square root of little r squared minus y squared. Right? And so the plus or minus is there because of the two sides. So this side is going to be r plus whatever, and this side is going to be r minus whatever. And as you can see, when y equals 0, along the x-axis, this is just going to be the square root of r squared, and that's just going to be r minus r, big R minus little r, or big R plus little r, depending on where it is. So now you have the two radii in terms of x, and since you're revolving around the y-axis, you should integrate it in terms of y, or with respect to y anyway. So the integration for a washer is going to be pi, and since pi is a constant, we can have it inside, times, and you need to have this is where you find the area of the washer. So you're going to have the outer radius, which is going to be r plus the square root of little r squared minus y squared, minus, and then let's see, big R minus the square root of little r squared minus y squared dy, and the interval of integration is going to be just from the top to the bottom of this, or from the bottom to the top of the circle, and that's going to be at y equals negative r and y equals r. So it's going to be from negative r to r. And so if you just FOIL this, it actually gets really nice because it all cancels out, or almost all cancels out. So what you're left with is pi times the integral from negative r to r of 4 times big R times the square root of r squared minus y squared dy. And then since big R is some arbitrary constant, we can pull the 4 in that out, so we get 4 pi big R times all that. And now we can use our trig substitutions to solve this. We just get the triangle, right? There's theta, there's a right angle, and the hypotenuse is going to be r, this is going to be y, and that's going to be r squared minus y squared. And so from this, we get that sine of theta equals y over r, y equals r sine theta, dy equals r cosine theta, d theta. And so we take this and we plug it in here, and what we get is 4 pi r times the integral of r squared, or little r squared minus little r squared sine squared theta. And so then we replace dy with r cosine theta d theta. And then we have to convert the limits of integration, or the bounds, to polar as well. So we get r equals r sine theta, and negative r equals r sine theta. And so you get sine theta equals 1, in which case theta equals pi over 2. And then you get sine theta equals negative 1, in which case you get that theta equals either 3 pi or negative pi over 2, but we're going to do negative pi over 2 for the purpose of this. So the integral is going to be from negative pi over 2 to pi over 2. And so here you can factor out an r squared, so that's just going to be 1 minus sine squared, and then you can pull r out here as the same you can do with this one. So 4 pi big R little r squared times the integral from negative pi over 2 to pi over 2 of this. And then 1 minus sine squared is equal to cosine squared. The square root of cosine squared is cosine. Cosine times cosine is cosine squared. So what we have now is 4 pi big R little r squared times the integral from negative pi over 2 to pi over 2 of cosine squared theta d theta. So now for this, we can use our square identities. So cosine squared is equal to 1 plus cosine of 2 theta all over 2. So we're going to get 4 pi big R little r squared times the integral from negative pi over 2 to pi over 2 of 1 plus cosine 2 theta over 2. And we can pull out the over 2 since it's a constant and make this 2 pi all that d theta. And then that's probably the easiest to integrate you can get. So you get that, and then theta, because that's the antiderivative of just 1, plus 1/2 sine 2 theta from negative pi over 2 to pi over 2. All right, and then this you just plug in. So you get 2 pi big R little r squared times pi over 2 plus 2 times pi over 2 is pi, sine of pi is 0, so that's just going to be 0, and minus negative pi over 2, so it's plus pi over 2, and then minus 2 times negative pi over 2 is negative pi, sine of negative pi is still 0, so that's also 0. So what you get is 2 pi, or this on the inside is going to add, is pi over 2 plus pi over 2, which is just pi, and you multiply that, and you get 2 pi squared times big R times little r squared, and that is the volume of the torus. My name is Matthias Herbner, and this has been my last math video for Challenge 2016.